submitted your science as a draft on Seesaw, friends. You might want to pull that back up because we're going to pick up where we left off yesterday. Oh, wait. No, you didn't have a draft because I saved it as 2 different assignments. Okay, fine. You should have an assignment for today as well. And we're going to pick up where we left off. My friends, pull out your worksheet from yesterday and here in person. Yep, that one. All right, let me present, and we're going to get going right where we were. Mystery, Doug. Here we go. Let me mute.
Why did the vinegar and salt make the penny shiny? You might have had different ideas. Before we can answer this, we need to think about other questions that might have come up while you did this activity. Like, why are some pennies dull and dark brown at all? Well, have you ever noticed that pennies have a year written on them? Like this one here, it says it's from 2002. If you pay attention to the date on each penny, you might spot a pattern. Have a look at these pennies. Do you notice anything? Take a few seconds to look. Okay, you ready? You might have noticed it's the older pennies that are dull and dark brown, and only the newer years still look shiny. So pennies don't start out dull and dark brown. When pennies are first made at a place called the mint, they're made using shiny, brand new metal. They only get dull and dark brown over time. What is this dark brown stuff then? It's tempting to think maybe it's just dirt that's building up over time as the pennies get handed around.
All right, lots of hands raised. Lucas, yes, sir.
So I think the older the pennies are, they make them like kind of like a symbol. Darker is older, the brighter is the new.
Okay, possibly. Cam, did you have a thought?
I think that it's just like rust. Pennies are like copper or like metal. I think they're rust that just builds up over time.
Okay, rust. It's just a sign of that it's older. Josie, what do you think?
I kind of agree with Cameron. I think that it's a type of rust.
Okay, Fiona.
So what I'm thinking, this is what I put on my paper, is like, if you remember how we dipped the pennies in the salt and vinegar water, the stuff came up and they turned into tiny particles. But what I think happened is that the same particles are kind of like floating around in the air, and as the pennies go in different things and you touch them, the particles fall back onto the pennies.
Okay, so she says that these particles, whatever these things are that is making the pennies darker, are always around us, and it's just getting on there when it gets in certain solutions or when it touches certain things. Okay, possibly. DJ?
I agree with Fiona, but I am going to be more specific. I know that there's water and oxygen in the air, and they kind of combine, and that is what causes the pennies to get weathered, and that's what it's like. It's like a mixture of like rusting and weathering that only copper does.
Okay, DJ's got way more specific, and Lily's about to shake right out of her seat. Let me catch them up in case they couldn't hear DJ. DJ said that he knows that there's bits of water molecules and oxygen in the air, and the water and the oxygen in the air are combining with the pennies to give them this darker rust-like color. Lily, what else?
I know the Statue of Liberty was made of copper, and then it turned green from like weathering.
Okay.
The penny had a little green on it.
All right, Lily noticed and made a connection that the Statue of Liberty was originally a copper color, and because of weathering with water and air and being exposed to the outside elements, it originally turned a darker color, but now it's a green color. The Statue of Liberty looks kind of green. And Lily's penny yesterday had a little bit of that same kind of greenish color on it. So she thinks that whatever happened to the Statue of Liberty happened to her penny. Pennies are made of copper, especially the older ones. The new ones are only copper plated, which means they're made of something else and then really quickly dipped in copper. Jason.
So, I had a question. Could we look at the Statue of Liberty when it was first built?
I could look up a picture of the Statue of Liberty when it's first built. I think there's a chance that Mr. Doug's going to do that for us here in just a second because I think he makes that connection. Okay, Zeke, one more, Zeke and Kane, and then we're moving on.
So, when money goes into rotation, like coins, they get really dirty as it goes on. But if you think, one thing I noticed is if you get your coins out of your piggy bank and after they're in the piggy bank, they collect moisture almost, just because when you play with it for a little bit, there's grease and wetness on your hands.
Okay. Zeke said that he thinks that somehow the pennies actually are absorbing and collecting moisture somehow, something about them, because he said if he were to get the coins out of his piggy bank or whatever that have been sitting there together a long time, they almost feel moist and sometimes they get stuck together and you have to kind of pry them apart. I have experience, and he says if you play with them, you almost get this kind of moisture on your hands. I have experienced that myself. Kane next, and then Josie.
Miss Bad, but there's
Kane goes first.
Zeke, did you have something to add?
So so we have this Mexican coin, and it's super greasy if you touch it, and it never goes away.
All right, Zeke was sharing that he has a coin from Mexico, and it always feels greasy no matter what you do to it. All right, interesting. Kane.
I've actually watched shows where they walk into these older cities, and there's all these lampposts that are all green and a tealy green, and they said they're made of copper.
All right, yeah. Kane said he watched a show where it was older city, and they were walking, exploring this older city, and there were all these lampposts that were made of copper, and similar to Statue of Liberty, they were that kind of tealish green color. Josie, last thing, and then we're moving on.
Okay, so you know how yesterday it didn't work right for the salt and vinegar? I think I did the wrong measurements. I didn't see that you did the measurements. So I put in a little bit more salt and just tried it again.
Oh, yeah, I can see it for sure.
Yeah. So I just wanted to share.
There you go. All right, yeah, I was just going to say ours definitely worked, and I did a few more while they were at recess right now. Here's one. I don't know with the lights off how well you can tell. Pin myself. So Jason, you weren't here yesterday. We tried several different mixtures. We tried to dip the pennies in soapy water. We tried to dip them in straight vinegar. We dipped them in salt water, and then we dipped them in one that was salt and vinegar. Salt and vinegar was the only one that seemed to get them clean. You guys can see the line on it. Okay. Yeah, you can see that line. And I've got a ton of them over here that you can see the same kind of thing.
Why would I not do any of that?
All right. So, yeah, I did a few more. I had some extra pennies that we didn't do yesterday, so I went ahead and did those as well while they were at recess just now. All right, let's continue and see what Douglas has to say.
But remember, you dip the penny in soapy water, and the brown stuff didn't come off. If you wash a brown penny with lots of soap and water, the brown stuff still won't come off. Soap and water can wash off dirt, so the dull stuff on the penny can't be dirt. Why do shiny pennies turn dull and dark brown over time? Well, not all of them do. Look at this one. Check out the year. You'll see it's really old. It's from 1909, over 100 years old. Now, I promise this has not been dipped in vinegar and salt. It's a penny that's been saved all these years by a coin collector. Notice the container that it's in. Now, it's hard to see what kind of container this is, but it's an airtight container. Even after 100 years, it didn't get dull brown like most pennies do. So pennies will stay shiny if they're sealed in a container with little to no air. Whoa, so the reason a penny turns dull over time has something to do with air? I don't know if that surprises you, but think about it. You can probably think of other situations where exposing something to air causes it to change color or appearance. Like certain fruits and vegetables, an apple, a banana, an avocado.
Miss Bab, you're muted.
I was just asking, what's going to happen to those fruits if we leave them just like that? They turn brown, right? You guys know what that's called when they turn brown?
They rot.
Not rotten and not mold. Nope. No, it's not mold. You can still eat them when they're brown, at least for a little bit.
They age.
Nope. He's going to tell you in a minute. DJ.
At least bananas, I know, they get overripe, like they just keep ripening.
No, that's not the reason it turns brown when the air hits it if you leave it sitting in the air. Yes, they keep getting riper and riper when they sit out, but that's going to happen whether you peel them or not. It's when you cut it open and the banana ages a ton, the inside, the actual fruit part that you eat. Apples, bananas, avocados. On the outside, they're protected by that skin, right? Their peel. But if you open it and just leave it sitting there, like if I left the banana unpeeled and left it sitting on my desk, I could leave it there for a few days and the outside would start getting more brown, but I could still eat it after 3 days. If I open the banana and leave it sit here, would I want to eat it in 3 days?
Yes.
It would probably be mushy brown by 3 days later. If I just opened a banana and left it over the weekend and came back, I promise you I'm not eating that.
You can make banana bread.
If I leave them closed until they get really brown and then I open them up, then I can make the banana bread. You're right. Overripe bananas best for banana bread.
Yeah.
You are correct. However, if your mom slices an apple for your lunchbox in the morning, by the time you get to lunch, it's got brown around the seeds and stuff, right? Okay. Let's listen to Doug and find out what the fancy
all
ones
of these things turn brown over time as they're exposed to air. It may seem
surprising,
but scientists figured out it's the process with pennies. You'll learn more about this in middle school. Scientists call this oxidizing, from the word oxygen, one of the gases in the air around us. So that's why shiny pennies turn dark brown over time. It has to do with air. Now, there's one more question I thought of, though. What do you think? Does the oxygen in the air turn the penny dark brown all the way through, or is it just on the surface?
Lily has her hand raised. What do you think, Lils? That was one of Lily's questions too. Lily, you're a regular old, we'll just call you Mystery Lily now.
Miss Fab, we could use a file, a metal file.
Zeke says we could use a metal file. Fiona said, oh my gosh, are we going to cut open a penny? All right, I don't have a tool to cut open a penny.
Yeah, you do have a
I
hammer.
do not. A hammer is not how you cut open a penny.
Get a nail, get a hammer, just go.
Josie, thank you for raising your hand.
My hypothesis is that I don't think that it would go all the way through because the inside of it is not exposed to the air. The only things that are exposed to the air is the outside, and the outside turns that dark brown. So I don't see why the inside would if it's not touching any air at all.
All right. I like your thought. I'm going to rewind to the banana that I leave exposed to the air. The actual banana fruit, not the peel. I'm not talking about the peel. I'm talking about the banana itself, the part I'm going to eat. I open my banana. I leave it sitting here. By this afternoon, it's going to be a little bit brown around the outside. But if I cut it open, will it still be all the way yellow on the inside?
No, you said if you
The longer I let it sit, will the darkness start getting deeper?
Yes.
Okay.
Yeah.
So the longer these pennies have been around, could the darkness go deeper on them? I don't know. I'm just asking. Josie said she thinks it's only exposed on the outside, but I'm saying, well, but the longer they've been around.
I do think that too, like the longer they've been around.
Okay. Kane, thoughts?
Okay, so I was just gonna say, if you wanted to cut open a penny, you're gonna have to have a saw blade that you don't want to get dull, or you need a titanium one that just doesn't dull.
All right. I have, he was telling me how to actually, what I need to use to cut open a penny, and I do not have a titanium saw blade with me. So darn it, we're not going to get to do that today. All right, Sean. Whoa, sassafras. We don't say shut up in this room. Carry on.
Okay, so.
All right, look at me. Hi.
Hi.
Talk.
Okay, so if it's a liquid at first, we're gonna have like little air bubbles in it where it could like
Then when it forms, it would have like air bubbles. It go through the air bubbles.
In the penny, is there air bubbles?
No, you don't know that. Have you cut one open yet?
Okay, Sean wonders if, since it's oxygen and it's oxidizing, if somehow bits of air are getting trapped within the penny somehow. Tiny, tiny particles, too small to be seen. Are there tiny particles of air getting trapped in the penny? Interesting thought. Jason?
One thing. So on our crystals, what if we suffocated them without air? Would it still grow crystals?
I don't know.
Always find a way here.
We don't have it. We don't have
DJ?
I was gonna say that like I already knew about that, as well as saying like it isn't just the air, it's the moisture in the air too, so it's still oxygen, but it's a little bit of moisture
Okay.
in the air, so it's still like, that's what I already knew that.
Miss Bab, you're muted.
Oh, I was saying the second part of the question was how are we going to find out if it's just on the surface or all the way through? Zeke said use a metal file, and Fiona wanted me to cut it open. I can't cut it open, so here we go. Yeah, Josie.
Well, I just noticed that after I dipped this in salt and vinegar, I set it down on my table, and after it's been sitting there for a few minutes, it has it on there a little bit, and it turned to like almost a solid. Like whenever I lifted up the penny, there was white streaks on this table. Like they came off by now, but I mean, it almost turned like a solid. Just made me wonder.
What kind of table? Is it a wood table?
Yeah.
You got wetness, moisture on wood.
It doesn't matter.
Well, yeah. You might
Yes.
want to put a towel or something under that so you don't mess up your table. You can stain the wood.
Yeah,
wrong.
the table.
You don't want your parents to get mad if you put in water. If you just leave something wet sitting on a wood table, it will leave white streaks. So put a towel.
I have no idea if this is a wood table, but
All right.
yeah, I think
Just
it
say
is.
you put a towel underneath that so your parents don't whoop your booty later. I doubt your parents whoop your booty, but I'm just saying. All right, here we go.
So is the dull dark brown just on the surface, or did it go all the way through the penny? One way to find out is if you were to scratch at a dull penny with sandpaper. So let's try it. Wow, you see that? So there's shiny new copper underneath. So pennies are only dull on the surface, where the air has come in contact with the penny. Now we can return to the original question. When we dipped a penny into the vinegar and salt, what did the vinegar and salt do? Why did this liquid make a dull, dark brown penny look shiny again?
Okay, Fiona just said, well, it took off the top layer, just like sandpaper did. But when he did the sandpaper, I don't know if you guys noticed, I'm going to rewind this like a split second. Go away. There were little bits of dust sitting on the table around it where he had sanded it. But when we put it in the salt and vinegar, guys, there's no dust particles in here. So what? Where did it go?
It melted to such tiny particles.
It melted it into the tiniest particles that we can't see. Tiny particles fell off into the bowl, then disintegrated. They are now the particles, all so small you can't see them. The brown is a type of rust. So that's what Josie put for her answer yesterday, her prediction. I read it bigger yesterday, so when she actually turned in her paper. So yeah, Josie said, like, remember when we talked about matter, particles can be so small we can't see them. So yes, what you guys are saying, possible.
Like it's microscopic.
The particles are so small we just can't see them in the solution.
Well, let's imagine the penny from the side like this. Now remember, before you dipped it in the liquid, the penny was all brown. We came up with 3 things that might be going on. Maybe you thought of one of these too. Idea number 1. Maybe the vinegar and salt removed the dull outer layer, revealing the shiny new copper underneath. Or here's another idea. Maybe the vinegar and salt added a shiny layer of copper on top of the dull layer. Or idea number 3. Maybe nothing was added or removed, but instead the vinegar and salt somehow changed the dull layer itself from being dull to shiny copper again. Do you have any ideas for how you could figure out which of these 3 ideas might be true?
Okay, Josie, how could we figure this out?
I never thought about that. I'm just saying. I never thought about that because I know that vinegar like stains stuff and bleaches stuff. I didn't not think about that it added a shiny layer. I don't know if I think it did. I'm pretty sure it removed it, but that's all I was saying.
All right. DJ, you any thoughts?
I told you yesterday that sandpaper would work.
I know you did, but I didn't want to give it away to the whole class. Again, I've already done all this last year. I know the answers to all of this. However, it's about you guys discovering it. Jason, thoughts?
It's taken off because when we saw it with the sandpaper, it removed it. It didn't add anything. It rubbed it off.
All right, Jason said he knows that it was removed because when they showed the sandpaper version of it, we could see that the particles came off on the table. The problem is there's no particles in my bowl. So
It dissolved.
you guys are like just for sure that it's dissolved. All right, let's objection to Jason.
Microscopic pieces.
Just with sandpaper, it could be different in the case of vinegar. It could have changed its place. It could have added a shiny later. But I also do agree with Jason because vinegar is acidic, but it's a different thing entirely. So it could have added or it could have changed. But just because a sandpaper works, it doesn't mean that that's exactly.
All right, DJ says that he does agree with Jason. However, just because that's how sandpaper worked on the penny, that doesn't mean that's how the vinegar is reacting to the penny, because obviously one is something that's very coarse and rough, and the other one is a liquid. Eyes on me, guys. Okay? Eyes on me. Jason, go to the hallway. Actually, just go to the office. Not putting up with it. Just go to the office. Bye. You can watch the recording of this later. Bye. Your show is not amusing to anybody except yourself. See you later. Nope, it's not. If you think it's funny, you can go too. Okay. All right. DJ also said, what if it's changing place? We're talking about chemical reactions here. Could the salt and vinegar have just reacted with whatever that is on the penny to turn it into something new? Just like heating up flour and sugar and milk turns it magically into a pancake and turns it into something entirely new. Could the salt and vinegar have reacted in a way to make it in something? Lily's shaking her head like, Miss Bad, you've lost it. You're wrong. All right, let's see.
Of the 3 possibilities of what the vinegar and salt were doing, how could we test them to see which one is true? Well, with idea number 2, shiny layer added, we thought of something simple we could do. If a shiny layer of copper were added on top of the dull layer, then there should still be dull brown copper inside it, underneath the shiny layer. So if we just scratched the shiny copper on one of the pennies after it was dipped in the vinegar and salt, we could test it out to see if there's a dull layer still underneath. Let's try that. Okay. We're going to scratch it with a piece of sandpaper really hard. It's still shiny. Okay, so we can see there's not a dull layer underneath. So that means we can rule out idea number 2, shiny layer added. That leaves the other 2 ideas. Idea number 1, maybe the dull layer was removed. Or idea number 3, maybe it changed in place. Nothing was added or removed. The liquid just changed the dull layer to being shiny. Now, hopefully you thought of some ways to test these 2 ideas as well. Here's one thing we were thinking about. If the dull layer were removed, then shouldn't we be able to see little bits of dull brown copper come off? Like, shouldn't we be able to see some of it in the liquid? Why or why not? What do you think?
All right.
Discuss.
I'm hearing a bunch of friends in class say, yes, this is what happened. They're just too tiny for us to see. Josie is nodding in agreement. Too tiny to be seen. All right. Kendall, what do you think?
I think that they were removed and we are super tiny that our eyes can barely see.
Our eyes can't see it. We need a microscope. All right. Let's see what Doug says.
You probably have some new ideas about why the dull brown penny became shiny. Answer questions 2A and 2B on your worksheet to revise your model. Your drawing can include things you can't actually see. Just be sure to label them.
You're muted.
I wasn't saying anything. I don't know why I was muted. All right. So you're just doing this part now. So you guys should have this. So do you, now that we know for sure, did this change your mind or does this just make you more sure about what you wrote? So if your idea changed from yesterday, draw it on there. If this was about the same as you thought yesterday, you can just write same thoughts as yesterday.
Okay.
Might make it easy for some of you because some of you were hot on the trail yesterday. Josie, yes, ma'am.
So we don't have that on the worksheet that we have today.
You don't?
No, it's 3 pages.
You just have a quiz?
Yeah, I think so. Mystery assessment is what we have. It's labeled Are Magic Potions Real? Part 2.
All right.
Also,
Okay.
can I explain my reasoning?
Yes, Josie, go for it.
Okay, so I think that it came off, it removed it, and they are particles and they're so small that they're like almost disintegrated in the water to where they're microscopic and we cannot see them. The end.
The end. All right. I like it, Joe's. Zeke.
So I learned something. So we know we did soapy water, vinegar, salt, water, and salt and vinegar. And so the salt in the vinegar must have some chemical reaction to the salt a lot in the water. It didn't clean it that much, and the vinegar didn't either. So I wonder, will the vinegar, they have to have a reaction that makes something new. It might have its own name, or it might just be salt
All right.
and vinegar.
Zeke?
What does the salt do to it? The vinegar that makes it.
It's
All right. Zeke. Zeke's little wheels are turning, and I like this thought process. Zeke said, okay, this is salt and vinegar, and it worked, right? It did something.
Yeah.
But we also tried just salt. Not really anything happened. We also tried just vinegar. Not really anything happened. So he says there has to be some sort of chemical reaction here. The salt and the vinegar together are doing something. He said maybe they are making something new because on their own, neither of them did anything. But when they're together, something is happening. He says maybe they are creating some new kind of a liquid or solution that has its own special name. We've created a potion, a magical potion. Maybe Josie's modeling her magical potion as well. Okay, so Josie's reasoning sounds really solid, but I'm not gonna lie, Zeke's ain't so bad either. Like I'm hearing both of you, and all right.
I think I just said that
He missed that.
fine.
Oh
Does it turn into acidic acid?
Does it turn into an acidic acid? Let's find.
Here's a thought we had. Maybe there are little bits of dull brown copper in the liquid, but it's just such a tiny amount that you can't see it. If so, maybe we would be able to see it if there were more dull copper put into the liquid. Go to the next step and we'll test this idea.
Just drop all the coins in there.
Kaylee, what are your thoughts? Yeah. Okay. All right. All right, guys. So Josie's theory and many of your theories are that there are particles too small to be seen in here. But if there was more and more and more of it in there, do you think we would eventually be able to see it? Okay. How could we possibly test that? All right. Lily says get the dirtiest pennies, and Sam says stick them all in there.
Yeah, let's do a Sam's idea. I want to see what they all do.
Josie, your thoughts.
Okay, I have a question. So what did Zeke say?
Zeke said that because we tested the salt all by itself and nothing happened, we tested the vinegar all by itself and nothing happened. But when salt and vinegar were together, we know that something happens. So he's saying that the salt and vinegar together created a new chemical, like had a reaction, a chemical reaction with each other that created a new chemical. And maybe it is just changing the penny because it's putting some sort of new chemical that we didn't know about on.
Okay, so I like Zeke's reasoning. I still believe that there are microscopic pieces of this in there, but I do like Zeke's reasoning about how we tried both different things separate and that they made a chemical reaction to make something different. I feel like it might be a mixture of both.
Okay. All right. Okay. So in order to find this out, we need to figure out if reason number one was true. Was there dull stuff removed and we just can't see it because it's so tiny? So I like Sam's thoughts that maybe if we somehow could just get more of that dull junk in there, we would be able to actually see it with our eyeballs. So thoughts are that maybe we just dump all the dirtiest pennies in there and see what happens. Hang on. Josie, yes, ma'am.
Okay, so are we going to need the paper that he said we mark if we have something different in our thoughts? Because
No, don't worry about that. I'm not afraid, so don't worry about that. Okay.
Let's test out the idea. Dump all the pennies you tested today into the salt and vinegar and give them time to soak. In the next mystery, we're going to take a look at it and see what happened. Stay curious and see you next time.
All right.
I only got this one penny. I'll go get my bank.
All right, I've got all the pennies up here, plus a few more that were extra, and I'm going to dump them all, and we're going to let it sit over the entire weekend to see what happens. I don't know if you're going to be able to see anything right away.
Yeah, but like they started like disintegrating in within like 2 seconds.
You can't see. Yeah. That's what I'm talking about. Woo.
Oh, my Lord, one ran away.
I can't believe you.
All the pennies went home, but one ran away.
What are you doing, man?
They're all already shiny.
All right, we're going to check back on this when we come back after lunch. We're just going to let them sit for right now. All right, so right now what you have is actually a quizzy quiz on everything we've talked about the last couple of days. We're going to let those just sit for a little bit. I'm going to put the lid on it just in case there's some sort of tragedy, because I really don't want vinegar spilled all over my desk. Now, so what you guys have is a quizzy quiz with a couple of questions about this lesson.
It's the
Yeah, why is it he?
for a grade.
Miss Bab.
Where is it?
What did you say, Sean?
Hang on. Maybe I can't find it.
It is.
Oh, I can't find it. Here it is.
It's bad.
All right.
Miss Bab, look at that.
Ooh, wow, very interesting.
Is that metal?
Okay. I'm going to pass these out. We are good to go for today.
Nick,